Again, it's used as an interesting question. It's 2 to the x equals x to the 32. We did it by paper and pencil. We got an answer of 256. We did look at the graph. Our graph is indicate there's 3 points of intersection. We saw for one of them, paper and pencil, 256. And then we used grapher and come up with approximate solutions, approximately plus or minus 1, by the way. But I do want to go to Newton's method to find out these answers over here, and I'll go through that. And again, it's all typed up for you, but I want to point out, reset. That kind of clears out anything I got stored. F of x, and f of x is 2 to the x minus x to 32. And what we're looking at is for roots of the problem, right? We're looking for zeros. And then Newton's method, and what's that going to be? X minus f of x divided by the derivative of x with respect to x, all right? Then we need to make an initial guess. My initial guess was x equals, minus, I'm going to say about 1. Use a decimal number over there. And now I'm going to get another guess. And the way I'm going to do that is x equals Newton's method. Whoops, sorry about that. And I want to display the x, but I want to approximate it. And what do I get? And I get that number. And I'm going to do it again. I want to see if it changes. And it does. It changes again. I'm looking at it. It's keep changing, by the way. It's subtle change, but it's a change. I noticed that just looking at the end digits. Change still. And looks like there's no change over there, like 0.97901, all right? And that's what we're getting over there. Now I want to point out, we also type it up for you. It's right over here. But I want to do the other guess now. What's the other guess going to be? I'm going to say it's somewhere around 1.1. Changing my guess now. And I'm going to do Newton's method again. And I get a new guess. That did change. Do it again. That did change. I'm going to do it again. That did change. I'm going to do it again. That did change. I'm going to do it again. Let's see. That did change. I'm going to do it again. Yeah, there's a change there too. It's a small change, but there's a change nonetheless. All right, I want to point out, it seems like Sage is bogging down at this point. And the reason that it's actually computing a lot of computations, by the way. And if you looked at the display of it, it'd be all over the place. But I'm looking at this, it's still changed, by the way. All right, what am I looking at? I'm looking at the end digits. And this is within precision of the machine. The machine's got certainly when it's doing this, it's making an approximation with that dot end notation. But again, you notice it's pausing at this point. And what's happening over here? The machine's not slowing down, by the way. It's only using one of the processors. And over there, I'm going to say it didn't change now. So looking at this thing over here, I want to point out, I got another approximate answer. Let me see how if that's written down for you. Yeah, it's written over here. And again, it's not bad. We're able to use Newton's method. Now, some people on the web are going to say use Lambert W function, but I do like using Newton's method to get an approximate answer. And we found 3 approximates. Let's go back over 3 approximates we found. This is a good approximate answer to that problem. The other good approximate was this one over here. That's an approximate answer. And then we found an exact answer over here. Our graph also supports that, by the way. Thank you.